We have all of these other cuts to do that's located onto our handouts. Okay, so we do have to make those, but let's put that aside for now. And let's start on something a little bit different. Okay, here's what we are going to do. Get yourself in the XYZ coordinate so that you see this thing as is. You can put anywhere on this area. We're going to make another 24 foot by 24 foot by 24 foot cube. Okay, so if you recall the box command, select that. If you have the grid snap-on and O snap-on as well as the ortho, that would be helpful. But I'm going to select somewhere right about there. Doesn't really matter where, as long as I could type in at 24 foot, comma 24 foot. And that gives me another 24 foot by 24 foot rectangle. The height is going to be 24 foot again. And there I have its twin brother or sister, I don't know. Okay. What we're going to do with this one, let me move it further apart. What we're going to do with this one is to do a different type of subtraction to it. For those of you who are taking 101 class, the design class, you may have already dealt with this, but we are going to do a volumetric subtraction. Okay. If we could see these walls as surface cuts, there's a way that we could see this thing as a volumetric cut, or we could create a volumetric cut within this. Okay, and we'll show you the difference. Okay, so this is a building by Gwathmey Siegel, and it contains both a subtraction characteristic of a surface cut as well as a volumetric cut. So this right here, the entrance and the porch and stuff, this part that's taken out can be looked at as a volumetric subtraction. Whereas these windows over here, it's just happening on the surface, which might be considered a surface subtraction. So if we look at this object, right, it is dealing with some other things like the volumetric collision, which we'll deal with a little bit later. But on the interior, the surface cut is just a window. A volumetric cut creates a space or a area of occupation within that volume. Okay, so the slots become the surface cut, and the porch becomes something like a deck, which is like a volumetric subtraction. What we're going to do is to go ahead and create an object with a volumetric subtraction. Okay, so we'll practice making a little bit more boxes. So we have our 24 by 24 box. What we're going to do is to make another box anywhere on the screen, and that will be in the X direction. It will be 6 foot. Sorry, I should put at symbol, at 6 foot, comma 14 foot. Enter. And the height of this thing is going to be 16 feet. Okay, so I got 6 foot, 14 foot, and the height being 14 foot. Okay, so 6, 14, 16. What we're going to do is to move this box, move from the corner to the upper corner, or the bottom to the bottom corner, doesn't matter which. Select it so that we could get the gumball up, and we'll move it -4 foot, which will get this piece right smack in between this 24 by 24 length. what we're going to do is to do the Boolean difference again. -4. And cut this part out. Okay, notice this created a cut on the surface right here. This thing right here, let me get it to a shaded view. It looks like this could be a porch, this could be a wall on the inside. That is more of a volumetric subtractive condition, whereas this is a surface subtraction condition. Yeah. Okay. Next, we are going to make another box, but this time we're going to put it right in here. So if this is 14 feet and this whole thing is 24 feet, how much space do I have left? 10 feet. So that means that I have a 10 foot. So this X would be 10 foot. So what I'm going to do is to draw an object or a box at 3 foot, comma, 10 foot, enter, and then 6 foot high. And then I'm going to move this object from this corner to that top corner right there, and then proceed to Boolean it out. Okay. Let's say if I was really horrible in math, which I am, and I didn't know what length this was, okay? But I did know that I wanted it at least 2 feet high and again 3 feet wide. Okay, so if I didn't know what the length of this thing is, but I wanted it as 2 foot high and 3 foot deep, what I'm going to do is to make a box that is, let's say, 3 foot, comma, let's just use 24 since we had the 24. 24 foot, enter. And then the height of that is 2 foot. Okay, there it is. I know this is in the wrong direction, so we'll flip it around. So 90 degrees. All right. And I want this object to be moved from this bottom corner right there to that bottom deck right there. And of course, since this is 24 foot and this is 24 foot that I made, it's going to be stuck. Likewise, let me move this out. Likewise, if I didn't know what the length was, if I made a box that is 3 foot, comma, 3 foot, enter, and then, oops, I had to press the at symbol, huh? So a box at 3 foot, comma, 3 foot, enter, and I know the height is 2 foot. It's that thing right there. So if I move this from there, from that corner to that corner, it's short, right? So one thing that I could have done is to, if I could see the thing, so I'll turn her into ghosted, and then I could use the gumball with the shift and control keyboard push down. I could just select that face. Now, since I do have the grid snap on and everything is going to move at only 6 inches, I could just go close enough and then snap right into place, right? So there it is right on that area. Likewise, if I use this piece instead, move, I could, wrong one. I could select that piece and move it in to where it's hitting the object. Or, Control Z, it doesn't matter. All I have to do is, since I just want this piece taken out anyway, all I really have to do is to use the Boolean difference, select the object, select what I want to take out, and boom, there it's gone, right? So you could be exact, you could make it exact, or you could play it rough and then just take it out, take the subtraction piece out anyway, and it'll all work the same way. But notice that, well, this video is getting long, so we'll put it to the next one.